Okay, let's take a look at this rational function here. So we're given some function h of x, and you're going to see we like this form here. It's actually called factored form. It's not in the other form that we looked at earlier, but we're going to get to that. So just take a look at this guy so far. So we have some function h of x. The first step here is to determine algebraically the x and y intercepts. So let's do that. So to start, let's look at the x-intercept. Well, we know what the x-intercept, we're evaluating when y is equal to 0. So that's what I did in the next step below. Now, how can we go about this next step? Well, I want you to see here, if we multiply both sides of this equal sign, by x plus 2, these x plus 2 terms, they divide down to 1. And then on the left-hand side, we just have 0 times x plus 2, which is just 0. So we're left with a statement that says 0 equals 3x minus 4. Now, an interesting observation is if you have something in factored form, your x-intercepts will always be located in the numerator. There will be a factor in the numerator, and we haven't looked at point of discontinuity yet, but we'll get there. But right now, a term, a factor in the numerator will produce a x-intercept to some degree. So that's important to know. It won't exist in the denominator here. And we just proved it because we have to multiply both sides, whatever's in the denominator, to 0 on the other side, which will just 0 out anyways. So anyhow, we're left with this statement here, 0 equals 3x minus 4. And then let's just isolate x here. So I'm going to add 4 and then divide by 3. So that's what I get for my x value at my x-intercept. So we have that as my x-intercept. Okay, so let's go to the next question. The y-intercept. Well, we're going to evaluate it when x is equal to 0. And so I've done the first step for you. So we're inputting a 0 into our function. And what we're going to be left with is negative 4 over 2, which is just going to produce a negative 2. So our value here is going to be 0, negative 2. So two important pieces here. It's just going to help us draw our general shape here. And yeah, it's just going to help us with a sketch of our graph here, which we're going to have to do in a few steps. Okay, so the next step is an important step, and I want to go over this with you. So question B says, express the function in the form. So we want to put it into this form. Well, right now it was in factored form. This is in factored form. This is kind of the general form. This form is really important because it actually gives us some information about our location of our asymptotes, both of them, and then it gives us a parameter, which is actually ends up being our vertical stretch factor from the base function 1 over x. So the question says to express it in that form and then describe the transformations. So the first step here would be, let's get it into that form. So what is the steps to do that? Well, we're going to do some long division. So we're going to take that 3x minus 4, right? And we are dividing it by x plus 2. So let's go about that long division. So we want to multiply this to get to that. So what do we have to multiply x by to get to 3x? We would have to multiply it by 3. And then we can distribute that 3. So we're going to get 3x, and then 3 times 2 is positive 6. And then we're going to take the difference between those two. We want those 3x terms to 0 out. And then we're going to get negative 4 minus 6, which is negative 10. This is our remainder, which is an important piece of this. So what we essentially said, you can look at it a couple ways. Well, we said this 3x minus 4 is equal to x plus 2, which was our divisor, times our quotient, which was 3, plus our remainder, which was negative 10. So next what I'm going to do is I'm going to divide everything here by x plus 2. And the reason why I do that is if you look here, in doing that step, this is actually equal to h of x. So we rewrote the function h of x to to look like this. It's going to be, well, if you acknowledge, those are going to divide down to 1. You're going to get 3 minus 10 over x plus 2. I'm just going to write that in a slightly different way here, just to rearrange some of the terms. That's going to be negative 10 over x plus 2 plus 3. Okay, so we've now taken that factored form and we've written it in that other form, that general form, and now we have a lot of information here from this. What we have is this guy here, that first piece, that's going to be the location of our horizontal asymptote. That's going to be at y is equal to 3. The next thing that we can take away from this guy here, that plus 2, that's our vertical asymptote. That's going to be our vertical asymptote at x equals minus 2. We've got a couple more things here. We have, let's grab the highlighter. We have this a value of negative 10. So that'll help us with our description of the transformations here. That's a vertical stretch by a factor of 10 and also a vertical reflection. So let's piece all that together with a description of transformations, which is what the question was asking. So the first transformation here, and I'm just going to write this in shorthand. If you're doing this on a test or assessment, please make sure you fully write this out. But right now we have a vertical stretch by a factor of 10. That's about the x-axis. Okay, the second transformation here is we have a vertical reflection about the x-axis. Our third transformation, we have a vertical translation 3 up. And our last transformation here, we have a horizontal translation 2 left. So let's just put a little box around that. So we pulled all that from that equation. So that's why this form is pretty helpful. So what we can do next off of this is we can do a rough sketch of this graph. So I'm just going to jump down to question D here. Actually, let's fill in some of this table. We can fill in our x and y intercept here. Our x-intercept is at 4/3 and 0. Y-intercept is at 0, negative 2. And the equation of the asymptotes, we have one at x equals minus 2. That's our vertical asymptote. And we have another one at y equals 3, and that's our horizontal asymptote. So we can start sketching this thing. So let's go down to our grid here. So the grid doesn't have an axis here, so let's create an x and y axes. There's our y and there's our x. So anytime you have to create a graph, just make sure you label these accordingly with some arrowheads. Okay, so the first piece, let's plot those asymptotes in there. So let's use a dotted line to do that. So we have a vertical at negative 2. So we'll draw that in right there. And then we have a horizontal at y is equal to 3. So those are my two asymptotes there. Hopefully you can see that. If you want to identify them, you can do that off to the side. At y is equal to 3, and a vertical, if you want to put that down here. So we got our two asymptotes. Now, let's put in our x and y intercept there as well. So our x-intercept is at 4/3 and 0. So 4/3 is like 1 1/3 and 0. So that's like right here. And then our y is at 0, negative 2. So right here. Okay, so we can actually pretty much do the rest of this. Now, keep in mind, there was a vertical reflection here. If you look at the description for number 2 there, was a vertical reflection about the x-axis. So typically, the 1 over x function exists kind of up here and down here. Well, vertical reflection will put them down here and up here. So we're looking at the green stuff with a vertical reflection. So let's just move that all out of the way here. So our x and y intercept kind of supports that too. We can go like this, and we can go like that. And then on the other side, we can have just a rough sketch, something like this. And there you have it. That's our function h of x. So basically, we just took our function in factored form, got our asymptotes, got our x-intercepts. Oh, and then we have to actually do a domain and range statement. So we almost missed that. So the domain here, well, the domain is going to be the values x, but x in this case cannot equal -2, which is where our vertical asymptote is. And then our range is going to be where our horizontal asymptote is, which is 3. Okay, there you have it. Yeah, fully analyzed, fully graphed rational function in factored form.